Hello Internet, welcome back to our Voxel terrain video series. What we're going to be working on today, as you might be able to see, is we are working on a little algorithm. So we're going to whiteboard it first because I imagine, I'll get the camera or the light off of the whiteboard, but I imagine this might not be the easiest thing to follow. So what we want to do is we want to insert with a circle. So we want to give it a point and a radius and say, turn every voxel in this area on, or turn it off, or whatever. Set it to whatever value we need. And so that's not as easy as it initially appears, because the easy solution is just to loop over all the leaf nodes and see if they're inside the circle or not. And we could do that. But if the entire thing's full, then even if we're doing a small circle, we have to iterate over every single node in our tree. And I don't want to do that. So I've come up with a way where we can actually kind of cut that down. And so if this is our occ tree, for example, and down here, these are our smallest nodes. Let's say we want to do a circle here. So this will be our point. And then we have a radius like, let's do like something like that. So you get a general circle like this. So what we want is we want to iterate over every single node starting at the top. So we start at the top of our tree and we see, is the circle inside of it? In this case, our circle is actually inside. So we go in. Next, we go to each of these. So we're at this point now, these nodes. I don't know if that helped at all, but we're there. And we're going to do that for all four of them. And all four of those are also in there. So for each of those, we go down. For these three, there are no children. So we ignore those. We haven't gotten to there's no leaf nodes there. So this is just going to repeat over and over again until you get to a leaf node. And then if it's a leaf node and you would continue, then you know you have something inside of your circle. So in this case, we'll go into here and we'll see these three are inside. How we define inside is going to be a little bit, we're going to have to kind of mess around with it. For now, I'm not entirely sure how we do that. So we need, so there's a few ways we could do it. We could obviously take the center point of every single node and calculate based on that. But then, for example, if a circle is entirely inside of something, we would never find it because we wouldn't actually bubble down to it. So we need something a little bit more complex than that. And I think we can do a comparison between, like, if it's inside of those, oops, a little too low there. If it's inside of these bounds, then we know it's inside our square, and then we can check from that. So we'll be riffing on that because I still haven't figured that out entirely yet. We'll probably do that as we go, but we need to kind of experiment with that and figure out what's best for finding that. Then when we get down here, we set it. How we handle these edge cases, like here, it's kind of half in, half out. How we actually handle that is going to be something we're going to have to come up with. It could be we say, if the circle is in it at all, then you want to say, yes, this is something we want. I think that'll probably be the easiest. If we don't want that, we'll probably have to give it some sort of padding. So if this is our circle, we'll have to give it some padding based on the size of the leaf nodes and prevent it from going like that. But this is the general idea. So we burrow down and we have leaf nodes here. What would actually have to happen is if this was an add, we would have to add here, 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 here. We'll just say here and here. But then we'd also have to subdivide here and add those two. And then we'd have to subdivide here and then subdivide here and subdivide here. Add there, 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 and there. And do that for all of them. And so you can kind of start to see it pop out, but we're getting sort of a circle shape. And so this should be configurable, and we should be able to kind of go down. So it'll probably cause quite a bit of subdivision in our octree, but it should be the optimal way, because let's say we put a point right in the center there, and then this is our circle. We only eventually go down the length of the, or the height of the tree, and then however many nodes end up falling in there, and no additional ones. So worst case, it's actually going to be, like if you do a circle that takes up the whole thing, that's going to be slower, just because our algorithm is going to have to burrow in. But if you do it this way, theoretically, for the average case, it should be better. At least I am hoping it will be. And we may be able to do something smarter to get that edge case faster. But I don't really care about that right now. So we're going to try to do this, and that's going to be, hopefully, by the end of the video, that's what we'll have. Don't know how far we're going to get. We're going to see. So I'll be right back. I'm going to put this down, and then we'll get to the code. So BRB. Okay, so we're back. Just to catch everybody up, this is what we have right now. We have this simple mesh. We added the texture at the end of the video last time. And so what we can do is we can kind of draw voxels, and it automatically refreshes our mesh every time as we do, which is pretty cool. And so what we want to do is we want to go through here and actually modify our Quadtree pencil. We're going to create another one, but it's going to do the same thing. And we want to actually insert those spheres. So let's name it correctly this time. Oops. Quadtree sphere inserter, I guess we'll call it that. So there's nothing here, but we should be able to just copy this. There's nothing super fancy going on here, so it shouldn't be a problem. And so now that we have this, what we want is we want to take this insert here and do sort of a insert, either an insert sphere or insert. So really the question is, do we want the inserts to be handled by our Quadtree? I think the answer is yes, and that's mostly because I don't want this logic. Like I want to know that I'm using a Quadtree because I know the complexity of using a Quadtree, but I don't want to know that I'm using a Quadtree because I don't want to use Quadtree specific functions outside of a Quadtree, because if we ever want to change it in the future, suddenly everything breaks. These inserts, that would work perfectly fine if we switch this to just be a flat grid. If we started doing subdivision calls outside of it, that doesn't work anymore. So we're going to keep all of our Quadtree specific stuff in the Quadtree, which means that oops, I forgot I can't do that. I need to actually install Intellisense. That would be smart. Let me actually do that. Hold on. I'm going to go and install the plugin for Unity, and we'll be right back because this is starting to annoy me and I don't like it. So BRB again. Alright, I don't know how I fixed it, but it's fixed. And my camera is getting all out of focus. What is going on? You alright? You don't look alright, camera. You're kind of freaking out. You good? Hey, it's good. Cool. So, it's not good. Okay, my camera may not be healthy. That could be an issue. Anyway, we're going to continue on, and if that just goes horribly wrong, then I may be a bit blurry, and I apologize for that. So that was probably super quiet because I was kind of mumbling because I was kind of annoyed, but we're going to work on this. So the first thing I'm going to do is actually switch this to get mouse button down. And this is just so you have to click, and that's because our spheres we don't want to just blanketly like click and drag to insert a sphere. At least I don't think we want to. So we're not going to. And then the other bit we need is not a Quadtree component, but a radius. And we'll set it to like 0.25f. And we just want some sort of 0.5f, but we'll want some sort of radius for our circle. And so we've got that. And then we just need insert circle. I guess that makes sense. And so we want a point, a radius, and then the value. So all we need to do is plug in the extra radius here, and then modify everything. Ooh, that's wrong. My hotkeys are still broken. I reinstalled everything, and they still don't work. That's too bad. Okay, I guess we'll do this the old-fashioned way. We need a modified insert. Public void insert vector2 of the position, the float of the radius, and the type of value. There we go. And we're going to do something fairly similar. We're going to subdivide until we get to where we need to go. But our subdivision is going to have some strings attached. So currently subdivide is a recursive call, and we'll just keep going down. We actually want to take that out, and we're going to have to do the recursion ourselves. We're not actually, are we going to do recursion? Recursion is probably actually a good idea. Yeah, so we are. But we are going to need something else. So this is insert circle. And so it's going to iterate over all of that and return back the leaf node. We don't necessarily want that. We are going to want a full list. Camera's still freaking out. I apologize for that. Actually, I'm going to pause and fix that, because this is going to get really annoying because it keeps blurring and losing focus. I don't know what's wrong. So let me fix that. There's so many stops in this video. Anyway, I'll fix it, BRB. So what we need to do is for our circles, remember our logic was to first see if we're inside of our node, and then subdivide that. The issue is this is only going to return one leaf node. So I think we're going to need a modified, we're going to need some sort of modified subdivision. It's still going out of focus. Why do you do this to me? Camera. Whatever. I tried to fix it. It's being weird. I think my setup's all sorts of messed up. What can I do? No, that was not the answer. Okay. This is not going well. So, what we want to do now is take this circle and then subdivide each of the nodes, but only the ones that are inside of where we are. So, do we make it like a conditional subdivide? Yes? Question mark? Yeah, so we're gonna I need to think about this one because I don't know what the best solution is. Here's what we're going to do. We are actually going to copy this, which I really don't like, but we're going to do a circle subdivide, which I also really don't like. And so this is sort of something that I just do. I'm not sure how good of an idea this is, but if I'm, like in this case, we're kind of up against the wall. We don't know what is wrong. So well, I know what's wrong. I don't know how to fix it cleanly. So what I'm going to do is I'm going to implement it again. Just copy and paste it, and then we'll modify this one to do what we need here, and keep the other one for our just normal insertion. And then we should be able to walk it back and kind of collapse everything down until it all kind of fits where it needs to fit. So a circled subdivide is actually going to return a list of nodes. So I think this is another chance to use our yield. Okay, let me see if I can. How's that? Will you stop freaking out? Okay, cool. So what we're going to do is we're going to yield return our current instance if the depth is 0. And that should get us down to where we need to go. And so then, if I'm thinking about this correctly, that's just going to return up one level though. So we need to propagate it all the way up, which we can't do that way. No, sorry. It's been a long day. I say that, it hasn't been a long day. It's been a pretty great day. I did a lot of fun things. Came up with some cool ideas. Some of them you'll see later this week. But anyway, I am totally flustered and this is not going well. So I am going to figure this out and then we're going to do this. And so how we're going to do it is yield return. That's what we want. We have this circle subdivision. We want that as well, but we don't want it here. And the reason is because there may be multiple nodes that we actually want to go into. This isn't an exclusive thing. There may not be one point that we're searching for. We're searching for a number of them. So here we create our subnode I. I'm gonna use that, and then we're going to recursively call each of them. But there is one condition: if it's within our circle. So if subnodes I dot contains circle, or contained in circle, sure, and we'll give it our target position and our radius, which we didn't pass in. So if it's contained in our circle, then we continue to subdivide it, and if not, then we ignore it. And then the only other thing we need is to actually pass down our radius, like that, and then we just need to implement this. I kind of want to do this in an extension method, but for now we're going to keep everything together, and then we'll split it out later after we figure out where this is actually going. because I kind of want all of this math outside, but right now it's kind of all jumbled together. I want to take all of the math solver bits that are actually figuring out where things are and actually pull that out. So this contained in circle, that whole if statement, I want outside. And the reason is because if you can plug in your own solvers, that way you can actually do a lot of fun stuff. So you can insert squares, or you could do like lines, or whatever else you want. You can't do it if we hard code it like this. So that's a long-term goal. We're not going to do that now because that's going to take longer and it's going to be more complicated to do just from the start. Let's do the simple stuff and then let's make it harder. Say simple. I've been struggling really hard with this. So it needs to return a Boolean and be contained in circle. It can be a vector 2. And it's going to be, oh, that's wrong. So it's going to be the position of our circle and the float of our radius. There we go. And so we should be able to just test this. And it should be relatively easy. We're going to have a square and a circle and see if our square and our circle overlap. Even a little bit. If they overlap even a tiny amount, then we're going to say, yes, it's in our circle. I understand that may not be ideal, but it's what we're going to use. So this is just simple square circle collisions that I wish I remembered how to do. Camera, stop freaking out. You're really getting on my nerves, and I'm sure that's annoying to watch. I apologize, I guess. I'm gonna stop worrying about it, but it's really bugging me. I don't know what else to do about it. So, contained in circle, we have a position and a radius. That's our circle. We also have a position and a size. It's a square, so it's going to be equidistant in all directions. So, how do we want to do this? Let's define a rectangle. So this is going to actually be, let's do it as vector 2s. We'll do the top left and the bottom right. So 2 vectors. And this one is going to be a new vector 2 of our node's position. So this dot position, there we go, dot x. And we're going to add our current size dot x, dot x divided by 2. And so this is going to be our size, or it's going to be the center minus half of the size, which is going to get us our left side. And then if we add a y value to that, or if we add the size onto our y, that should get us the top. And so I just did that for the bottom right, which is totally wrong, but that's what copy and paste is for. And so if we flip the signs here, we'll get the other side, like so. And now I'm thinking I didn't want to do that. So the reason I'm thinking that is because we don't actually care about that. What we care about, sorry I'm reiterating over this, I've had a number of ideas about this, and this whole plan was kind of something I've been throwing together, just thinking about. And so it's all kind of coming out in just random directions, and it's not going great. So new vector 2. And this is going to be the difference between our position and the position of that. And so that will be just the straight difference. There's nothing fancy going on there. What is going to be fancy is we want to then take the difference dot x and set it equal to the math maximum of 0 or the difference.x minus the size divided by 2. And so what we have is the difference between this and the outer point. And so what we want to do is actually take that difference. So we have the x and y difference of our center of our square and our circle. And we want to actually get the outside edge. And so the way we do that is we actually move it towards that. So this is getting us our actual difference, which we want an actual absolute value over this. So we'll get the absolute value of our difference and then subtract half of the size, which will get us to the edge. And so if we do that for both sides, that will correct for that. So this correction will be greater at corners and less if it's just over the side, because y, for example, may not correct fully, even if it is way outside, and that's intended because it's a circle or it's a square. So that should get us our correct difference between the points and the outside edge of our square. And then we just need to see if that's within the radius. So Pythagorean Theorem, which is going to be the square root of x squared and y squared. So the distance is actually going to be, we don't need to do this, it's already calculated, just the magnitude. So if our magnitude is less than our radius, then it's inside the circle. So we can just return that. And I don't know why it took us so long to get there. So difference.magnitude is less than the radius. So if our difference is within our radius, we're good. And that should solve everything. I'm saying that with hesitation because I'm pretty sure that isn't going to solve everything. So we want to subdivide our circle in our insert circle. That's going to expect a radius. And now it's going to subdivide circle doesn't exist. What? Oh, circle subdivide. Of course I'd call it that. Why would I call it the other thing? That would make too much sense. So we have our leaf nodes. Can we just? Yes. So for each node in our leaf nodes, we want to set the value like that, and then notify. So this should do everything because our yield here, all the way down here, should return all of the leaf nodes we get down to, and then we'll figure that out from there. I don't think there's anything else. We can find out pretty easily if this worked or not. So let's go here. We can actually stop that quick. And I'm going to just disable the pencil and throw the sphere inserter on there. Connect everything up and hope it doesn't throw a ton of errors. Or hope it does something. I don't think it's doing anything, which is a problem. What have I done? Nothing good, apparently. That's unfortunate. Now we have to figure out what is going on. And my guess is that this yield is wrong. But how do we make it correct? So what we're doing here is we're returning our node if we get that far, and then we want to actually bubble all of those nodes up our subdivision tree to wherever it was. but I don't think we can do that. Yeah. Yield break to end the iteration. No, we don't want that. I'm doing something wrong. So we should be able to fix this. Let me see. Circled subdivide. That's all good. You should get here. And I'm going to put 2 breakpoints. One at our contained in circle and one at our return this. Just to see if we hit that, we know something's working. And then this contained in circle is totally different. And we just want to see if that ever returns true. Just for safety, I'll put another one there. Why do you keep popping up? There we go. So let's start this again. And we should be able to click. And we're not getting anything at all. That makes even less sense. I believe I have destroyed it. And everything has gone horribly wrong. What have I done? Something awful. So we have a depth first search, more or less, going on here, trying to find everything inside of our circle. Problem is, we're not actually finding anything, which isn't good. Okay, so let's just walk through it and see where things end up. Subnodes is definitely not null. I said that. Why, are you trying to make me wrong? Oh. I stepped over it. Of course I did. It made too much sense to do anything else. Let's try that again. So, just to confirm, radius is 0.5, value is true, target inside of our tree. What is going on? Why is it exiting there? Oh, if our subnodes is equal to null, then we do that. Otherwise, we just skip it. Now, that makes sense. So it's a logic error. I can fix those. Yeah. Okay, cool. That actually makes that way easier. So we can actually do this. This will probably be fairly straightforward. We can just copy that and move all of this down here. And so instead, what's happening here is we we have one section here that's going to be actually generating our tree, and another one that's actually going to be burrowing into it and actually doing the test. So this is the part that we've kind of added, and this is all old stuff. So that should have fixed the issue we were having. It's going to be very angry at me because I just recompiled code while the Unity was running, which it really does not like. So let's stop it and restart and see what happens. Still not working. I'm going to remove that one just for now. Okay, I attached the debugger. Let's see if this works. And yes. So we do get to contained in circle. That's good. We have 4 nodes. Let's actually, for now, let's see. Okay, we do get into this. So our contained in circle does return true. So what's our depth at? 6. So we need to go quite a bit deeper. And we never do. How is that happening though? How do we not? Because that didn't make any sense. So we do this contained in circle check. That works. And then we do this. I'm starting to think I don't like this yield, so I'm going to take it out. And instead, at the very start of this, we are going to insert a, what do we want to call it? What are they called? Collection. So a collection is going to hold things, and I believe I'm wrong. We want an iList. I'll get there eventually. So an iList is going to hold a list of things, and it's a generic implementation of a linked list or an array list or things like that. Anything you can insert or remove from. So in this case, we're using it because this gives us the ability to actually, it gives us the ability to actually decide what data structure to use outside of this. And if we change it, it doesn't break. So we'll just do selected nodes. And so we want selected nodes.add, and we're just going to add this. And then we'll just return. Can't return. Yes, we can. We're going to remove our return type because that's always a good idea. So this goes away and just becomes a void function. Everything else is good. And then we just need to plug in, what do we call it? Our selected nodes. So we now have a selected nodes list that we're going to need to pass in up here. So let's make a linked list. A linked list is going to have constant time inserts and deletes. So we do a new linked list of our Quadtree nodes of our t-type. Then everything should be good. We can do a linked list like that. And it gets really annoyed because our types don't match up. Why don't they match up? Don't tell me you don't implement a list. I just said you implemented a list and you don't implement a list? What is this? So I believe that's actually intentional. The result is that it's just really annoying. So all of that thing about abstraction, we're going to ignore it for now. And that actually makes sense because we need to add last or something like that. We can't just add into a linked list because there's no context there, and everything has to be, everything in a linked list has a context. It's connected to something else. So without that, it doesn't really make any sense, which I believe is why that happened. It just annoys me every time it happens. So cannot assign void function. I am aware of that. And then we'll just rename this leaf nodes because that's what it actually is. Does not exist in the current context. It's because I spelled it lead nodes, which don't exist, and I hope they never do. So hopefully that fixes everything. It gets around all of the issues we were having. And it does. Cool. So now we can blast holes in this. and then insert it back. And it actually works fairly well. It's pretty quick too. So I'm going to up the threshold to like 1 on our Quadtree. And this is just so right now we have nothing. We have just a blank canvas. And so this way we can actually see it generate our Quadtree as we click. So if I click here, you can see sort of what happened. If I click on the side, we still get that shape. So everything appears to be doing what I thought it would do, which is reassuring because I didn't totally screw it up. And so we get something sort of like this, and we can insert craters or whatever this is going to look like. I was left clicking, which is just inserting empty objects, which is why that isn't working. But if I do that, you can see it works. We get that, which means we can do circle insertions into our Quadtree. And because we just have this radius here, they're variable size. So we can do something like that too. So we can do all sorts of fun stuff. We can make a cave or whatever. And actually, this is pretty cool. I actually kind of like this. So we can use this for like a missile hitting the ground or whatever we want. And it kind of just blows things up in a little bit bigger fashion than the pencil we had previously that was just doing one at a time. This is a big one. And because of the way we implemented it, there's only one update that gets called. So our mesh only gets regenerated once, which means that's not going to really take that much time. So if we look at like our FPS, for example, or better yet, let me pull up the profiler. We can just drop that down there. You should be able to see. You can't really tell, which I guess that's probably a good thing. But I kind of wanted to see it. Let me make this bigger. It will make it more obvious when we do an insertion. So right now, you can see our profile is right at the bottom. We should see a slight uptick in rendering as we do this, but I wouldn't really expect that. I would expect our scripts to take up more and more time. So obviously, we're getting significantly more usage as we start inserting that, and that's just because we're rendering in this mesh. But I don't think we're seeing any frame drops. I should actually know how to use the profiler, but I don't really. Nope, that's not helpful. Okay, so ignore everything that I just did because I don't know what I'm doing. But the cool thing is, it's fast. Like, pretty fast. We just dropped down to 20 frames a second, and that's because we are drawing a lot of vertices. I think we do a separate rendering for each one of the little squares there, which is not great, but it works. Actually, if we turn off gizmos, that's actually the slow part because we're doing that all on the CPU side. So, yeah, there we go. But we get 300 FPS, and we have a fairly deep Quadtree. There seems to be a bug where if we fill up the entire thing, it doesn't work, which is why it keeps blacking out. So, more work to do apparently. But for now, I think we can leave this here. That's pretty cool. We can blow things up. So what we need to do is we need to come up with a game that can actually take advantage of this. This is kind of inspired by Worms style, like terrain explosions. They do something a little bit different, but maybe we can play something like that. To actually use this in a game, there's no collision right now. We need to actually add that as well. But that should be relatively straightforward, so I'm not too concerned there. But let's come up with something that we can play this with. I've got an idea for this weekend. So there may be a live stream this weekend. I haven't figured that out yet. If there is, I will let everybody know. But if that happens, we're going to be making a game. And I have this crazy idea that it's going to be really stupid, but really fun. So we'll see where this goes. But for now, we can blow things up. And I think that's cool. So I'm going to leave it here. And if there's anything you guys want to let me know in the comments, go for it. I love your feedback or anything, any suggestions you have, things like that. Read all of it or try to. So yeah, if you've got something to let me know, have at it. So until next time, see you, Internet.